So you go to data analysis, go to regression. Once you click data analysis, a box is going to pop up. You will see regression highlighted. It is highlighted because that's what I want to do. If you want to do something else, you can pick, but because we are running regression, so I'm picking regression, just click OK. So when you click OK, you have this box pop up. And in this box, you have all these options. So remember I said the Y variable is the one that does not change. The Y variable is the dependent variable. It doesn't change. But the X variable changes, is the independent variable. So we are going to input the data in this box right here. So the Y variable is the cost. Remember, the cost is dependent on the unit because it is your budget. It is what you have to be able to produce this. So we're going to select that. And remember, this very example is the linear regression with one independent variable. We're going to do another one, which is the multiple regression with more than one independent variable. Independent variable is the x-axis, is the one that changes. Maybe your dependent variable is your budget, and your independent variable is your cost of production, is your salaries, is your marketing. No, each of them are different parameters, so that's why they are independent. So if you now run this model, I did the model before, so that was the regression model that you saw, and I'm going to interpret what those numbers mean so that you can use them to take decision. And we're going to write the mathematical model because that's what you will be using to impute your number. Without the formula, you cannot be able to use the number appropriately. So I'll show you how to write the formula also. So this is the y-axis. Click on that because I already ran this regression before, so that's why I have this, but I can also take it out. So for the y-axis, just click on that and pick cost. Cost is our y-axis, the y variable, and then you go to the x variable. You see this impute x range. So I'm going to go to the unit, which is the independent variable, and then I want label to show, and then I want new output. I want to show this in a new worksheet. You can also have it on the same worksheet, you know, but I want it in a new worksheet. And these are all plots. If you want to see the plots, you know, let me select the line plot. The line plot is going to show you if there's a relationship between the cost and the units. You will see a straight line. If there's a relationship, they will be close to the line. But if there's no relationship, they will be far apart from the line. If you know how to do this and you can explain this to your company, you are a guru. They'll just look at you with one kind of, oh my God, we have a guru in the house. So then you click OK. Automatically, it's going to give you your regression analysis. So we have our regression analysis in another worksheet. So I'm going to increase the font so that we see the values. Right. So this is the line plot, and I'll come back to the line plot. You can see I mentioned that there's going to be a line. Let me put the line. If you want to put the line, so I'm going to put solid line. It should actually come all the way down. So I'm going to put, no. So the line should actually come all the way down, right? But this is not what we want to do. You can see the relationship. So the line comes this way, except for this particular one. And we're going to see what this is because it's far apart. So it's far, far, far from the line. So there's no, for this particular variable, there's no close relationship with the other variable. That's why it's far apart. But this other one, and let me interpret before I come to this line. So this is the regression analysis. There's something I need to let you know about regression analysis. Let me go back to the slide so that when I come back to this place, you will understand what I am saying. I'm going to stop sharing this and I will share that slide again. So I'm just trying to take the box out of my screen. It's just disturbing me. Okay, right. So got it. So there's something they call R square. And this R square plays a very vital role in your regression analysis. So R square is, it explains how the changes in the dependent variable affect the independent variable. That's exactly what I said when I was talking about the line, that the relationship, if anything changes in your independent variable, is going to affect the dependent variable. So the R square is going to show the relationship. And for R square, it is always better that it's close to 1. If it's close to 1, I mean, that means that's 100%. But most times you don't always get 100%, except there's a problem. But if you have anything more than 90%, you're very good. Sometimes, depending on the scenario, some people accept 80, 85. But if you have an R square that is less than 80, or some people accept 75, but if you're going to like 60, you should just ignore the model and rerun it, or you change some parameters. Maybe you change your independent variable. And there's another thing you need to understand when you're running regression analysis. We have the R square and we have the p-value. That's predictive value. Another thing you can use regression to do is to predict the future. So if you have a predictive value, that's a p-value that is more than 0.5. Please note this. It is given. I am not the one forming it. That is the way the model is designed. So if you have a regression, if a p-value that is less than 0.5, please, you need to take that model out. You need to take that variable out. Let's say you have marketing spend that is giving you a p-value that's more than 0.5, then you need to look at the number or reduce your spend. If you reduce your spend and you're not spending as much as the amount you used to run this model, maybe you have something better. And then if it is less than 0.5, then it is significant to your model. You can use it to take your business decision. So those are the things I need you to understand. So we have this example, which is what we just run. So this is the question in this example, the regression analysis we just run. We need to write out the total cost equation. That's a mathematical equation that we need. We will write it out. I'll show you how that is. Then we have this unit. We have these different units to produce. And the last one on the list is 9,000. So the company has said, okay, if all I need to produce 9,000 units of my product is $295,000, how much do I need to produce 20,000 units? That's the kind of decisions companies like to make. Okay, so we want to scale up our production, but we want to take it to 20,000 units. And we are currently spending 275,000 to produce 9,000. So how much do we need to produce 20,000 units? So we're going to use the regression analysis to determine this. Okay, so I said, let's see how it works in Excel. I've already shown you how to run that, and I'll come back to the answer. So I'm going to stop sharing this and go back to, I see a lot of questions. I can't be moving from this slide to the question for now. Let me quickly interpret what this means. So this is the multiple R square. We can just ignore that. The most important from this regression statistic is the R square, this one. I'm going to shade it. R square is very important. And from what I explained, I want to believe that this is a very good R square. This is good because it is 90%. If you turn this to percentage, it's going to be 93% if you approximate this 0.92. So this is a very good model. This company can use this. However, let's see what's going on here. The p-value. Let's see the p-value. You can also see that the p-value is a very strong one. If you approximate this, remember I said if your p-value is less than 0.05, and the p-value that we have here is 0.007, which is 0.01. So this is a very good output. So the company can sit and say, okay, I'm going to use this model to run our, to take decision. And then we're going to write the, function right now. The y-axis equals the coefficient this coefficient, sorry, the intercept, this one, the first one here, which is equal to this, that's the B1 plus the units, this one, X1, multiplied by the amount you want to produce, 20,000. Please stop me if you don't understand. This is the equation that you will use to solve your problem. So B1, Y equals B1 plus X1 times the amount you want to produce. This will give you the amount you need to produce 20,000 units. So you use the regression analysis to run this. The reason why we are going ahead to use this, to take this decision, because one, our R square is super good, 93%. Two, our p-value is fantastic, 0.01. So we can go ahead and use this model. If this p-value is not good and the R square is not good, that means you cannot use this model to run your, to take your decision just the way we want to do. So we want to take a decision right now. So the first question, we have answered it. So this is the function. Y-axis, which is the dependent variable, the cost that we are looking for, is equal to B1, the intercept here. Remember, we're using the output of the regression to take our decision. So we are taking decision now. So because we're going ahead to use because the regression is good. So B1 is your intercept, your X1 is your unit. If you're doing multiple regression, under this unit, you're going to have more than one. So in my lineup, I'll show you in the multiple regression, which is the second example. So then we said we want to know how much to make, to spend to make 20,000. So I'm going to populate this. So Y is equal to this value. I didn't send you. X is equal to this value, 52867 plus, okay, I'm going to take that Y away, if not, it's going to distort my calculation. So it's equal to B1 plus X1 times 20,000. I'm going to hit the enter key. Okay, I get it. I get it. So I should actually put but I hope you get the don't mess me up today, right? So don't mess me up, but you already know what, I'll come back to that. So this amount plus 24.188, right, times 20,000. So this is the amount we're going to spend to make, this is the amount we're going to spend to make 20,000 units. So can I go on? Did you get the gimmick? The company already know that to make 20,000 units, they're going to spend $496,627 to make this. So you can see how easy it is to make decision with regression analysis. So the company can also say that if I don't want to make 20,000, if I want to make 10,000, how much will I be spending? So if you look at that, the value might actually change. I'm going to change it from the formula. So you can see that the value changed. So they can be tweaking, playing around this, changing the number. Okay, we don't want to make 5,000. If you want to make...
There are a lot of questions on a few things. Okay. Someone is asking here that if, how did you come about X1 was very popular.
Okay.
And somebody's asking, how did you come about the formula? I don't get the equation. Is there something you can help clarify?
So
Thank you.
The formula is given. If you want to use regression analysis to take a decision. Once you have your output, this formula comes with this model. The y is your dependent variable, the y-axis. Remember, the y is the cost you want to find. Remember, you want to solve a problem. So the y is the cost. How much does it take to make 20,000 units of my product? If we go back to this data, this is the cost to produce this unit. So the cost to produce 9,000 is this. So they now said, how much do I need to produce 20,000 units of my product? Which is why we are solving that problem. And that formula comes with the model. You cannot change it. That's how they use it to run it. So you better know it. So the y is the cost, is what you're finding, what you're looking for. And what you're looking for equals to the intercept. The intercept is always in your regression output. So this is the intercept here. You will always see it there. So that's the first thing. So your B1, your X1, whatever you want to, letter you want to use is your intercept. And you will add it to X1. Your X1 is the first unit. Is the first unit. And you're picking this unit from your regression analysis. That is just it. So, and we are multiplying that by the quantity we are trying to find, the 20,000 quantity. If we run the other one, you will see how we merge units that are more than one. It's still gonna be the same, because when we finish here, it's gonna be plus B1. I mean, when we get there, I will show you how that is done. So I hope we understand. So if I change this is the formula now. This is it. This is if you look at the formula bar right here, you're going to see at the formula bar how we got that. And because I changed that to 12,000, if I change it back to 20,000, which is what we are finding, it's going to give us this amount. So you can easily tell that, okay, if we want to produce 20 based on the data that we have, or based on regression analysis model, because it is good, we can use this to take decision. Remember the determining factor, you know, the two things you should look at. You can also look at your significance F, but sometimes if you have good p-value and good R-square, you can go ahead and use that model to take your decision. I just hope you're understanding this. This is more technical. This is more technical. And if you know how to use this model to run your regression and to take decision, you'll be a go-to person, especially if you work in a place, in a manufacturing company. Even as a marketer, you can use this to take, the parameters can be anything. The cost can be you want to find out attendance into a class, what makes people attend the class. You can check the instructor. That's one of the x-axis. You can say the second X is maybe assignments, or another one, it could be, your parameters can be anything, but your y-axis, what you want.
There was somebody here saying that you typed 22 instead of 24 somewhere.
Okay, let me go back to.
Sorry to cut in.
Okay, here. Oh, that's right. That's right, sorry. That's right. Okay, so this is it's just the number that was different. So this is the answer. You're right. Thank you for correcting me. So if you change that number, it's gonna be, you know, it's gonna give you, thank you for noticing that. So you can't run away from tiny little details like that, but please pay attention. Thank you. So that's it. I hope we understand how this works now. I want to go to the multiple regression. Can we go ahead? Now I'm going to go to the multiple regression. So in this one.
All right. Do you mind if I just kind of do a check-in at this point?
Sure.
Hi, everyone. I hope the session is going well. We've just finished the regression, the first part of it. And we want to move forward, but we don't want to leave anybody behind. Is there anything we can help with before we move forward? We want to hear from you. How is the session going so far? We would like to kind of get an idea of where you are, whether everything is okay before we move on, to make sure that you're not left behind. The reason why you chose to come and spend 3 hours or 2.5 hours of your time with us is to make sure you get something out of it. So we want to make sure that you're okay. So we need your yeses or nos to make sure that we're on track. Anyone wants to help us put out a yes, I'm on track, or no, I need help, so we can know whether to continue. Thank you.
I see this is kind of technical, and people are kind of watching to see what's going on. Don't worry. Just make sure after this session, keep practicing. So to do the multiple regression, we have more than one independent variable. And this company produced 2 types of bike, the red bike and the blue bike. Okay, I think the first one I did, I used 3. Okay, so this company produces 2 types of bike, the red bike and the blue bike. And in this question, we want to find out the cost of producing 3,000 red bikes and 10,000 blue bikes. Remember here, the cost of producing, let me make it bolder. So the cost of producing the blue bike is, the cost of producing 200 blue bike and 300 blue bike, 200 red bike is 2,000. If you want to produce 500 red bikes and 600 blue bike, 5,000. Just like that, it goes all the way down. So if you want to produce 6,000 blue bike and 2,500 red bikes, you spend this. So the question now says, what is the predicted cost of producing 3,000 red bikes and 10,000 blue bike combined? So this is the equation. You can write it down if you want. Y is equal to intersect plus B1, which is the first unit, times X1, which is the first one, 3,000. So I'm gonna pick the pen. Let me explain this. So this is the equation. Now we're gonna use the equation to run the output we get from this regression to run it. So the company wants to know how much it will cost to produce 3,000 red bikes and 10,000 blue bikes. So this is the equation. To get this, you will use the intersect of the regression that we're going to get. You add it to B1, which we're going to get from that regression that we will run, times 3,000. This is the X1. 3,000 is the X1. And plus B2, which is going to be in the regression that we will run for this multiple regression, times B2, which is this. This is the B2. This is the B1, and this is the B2. So let's go back to the regression model. Right, so we're back here, and I'm going to run this regression now to see. So we go back to data, and then we go to regression analysis. I'm going to speed up a little because optimization is kind of longer than this. So we go to regression, click on that, and our dependent variable always is the y-axis. So we're going to pick that for the dependent variable. And then for the independent variable, okay, I kind of went beyond the scope. Okay, so it's cost. Make sure you highlight only the cells that have the data. If you highlight cells that does not have data, you're going to get an error. So the independent variable, why is it picking 13? It should be 10. Okay, yeah. Independent variable is the red and the blue together. So we have more than one. So for the x-axis, it's picking only the cost as the y-axis, and then the x-axis is going to be the red and the blue, which is the independent variable. And every other thing remains the same. We want it to come out in the new worksheet, and then we click OK. So this is the regression analysis for the one with more than one independent variable. Remember, the first one was just one independent variable, and this one has 2. So we want to see, okay, if we want to combine these two, what does it take? So to interpret this, let me bolden this a little bit. So this is the regression. This is the R squared. This is super good. This is 99%. This is so good. So this company is good to go. Let's go and see the p-value. So I'm going to highlight the p-values. Right. So this is the p-value. And we can see that the first one is 0.000. This is good. But that's a red bike is very good. The p-value for the red bike is good. But the second one is not good. But if we combine the two of them, we have overall good output, good model to use. So we can actually use this to take decision. But the company can say, after, let's see the mathematical function. Y equals intersect plus B1 times X1 plus B2 times X2. So let me explain this. Because we have more than one independent variable. That's why we have the X1 and X2 and B1 and B2. So the red one here, right here, is the B1. This is the intersect. This is given. So this is the intersect, and the red one here is the B1, is the X1, sorry. And the X1, this is the B1. The red bike is the B1. The blue bike is the B2. The X1 is the first amount, the 3,000 bikes, and the X2 is the 10,000 from the example. You know, in the example says, how much does it cost to produce 3,000 red bike and 10,000 blue bike? So the X2 represent the 10,000 blue bike, and the X1 represent the 3,000 red bike. The B1 is the result of that regression analysis based on the data that we use. And the second one, you know, is the other one, is the output from regression analysis based on the numbers that we use. Remember that this regression analysis cannot run on its own. You need data, and we use the historical data, okay, from what we have done before. Let me go back to that data. From what we have, that if we produce these two together, we will spend this. If we produce these two together. So I think the model has already used the historical data to populate that regression model so that we can run with it. So let's now look at the cost. Equals intersect 1117.18 plus B1 7.01 07 times X2, times X1, that's 3,000, plus B2, which is this one. Please stop me if you don't understand so I don't end up confusing you. 0.155. Now, okay, I'll come back to that. Times 10,000. If you hit the enter key, so this is how much it will cost you, 23,000 to produce this. Now, I'm going to show you something. If you look at this, if you look at the output, the red bike looks like it's more profitable. But the other one, the blue bike, is not so profitable. So if you go back to the model, remember that to produce 3,000 red and 10,000 blue bike, it cost us 28,000 this, you know. And this is affecting, I guess, this is affected because there's no much profit on the blue bike, and we want to make so much of that. Now, let me take out blue bike. from this equation and see how much the company will spend. So if I go back to the formula and I take out this blue bike and I hit the enter key, you can see that the difference is not much. So if the company produces more red bike, they're going to make a lot of money. They are spending 22,000, or let me take it the other way around. So if we produce only the blue bike, let's see how much that is going to be. So if I take blue bike, if I put blue bike here now, that's 0.155 times 10,000. You see, this is what it will cost the company to produce only the blue bike, 2,006. Okay, so the blue bike might not generate something better for them. So they would rather either they combine the two. It's better for them to combine the two and still, you know, for people that like the blue bike and all that. But they can decide to go either way, either to take out the blue bike or stay. Because if you see this now, also, this is not a good one, but it's riding on the red bike because the red bike is really very good. It's on positive and the blue bike is on negative. And look at this. This is so good. So the blue bike is riding on this. So they can decide to just, that's why you see some companies, they have two products and one is not really selling. I explained this when I was working in Nigeria. We had a particular product that was not selling, but the other one was really selling. So the one that is not selling was riding on the one that was selling. If we decide to discontinue the one that is not selling, it does not affect our company. But because we still want to have varieties, we just leave the product there. So that's how to use the independent variable and the dependent variable to take decision. Let me go to optimization analysis so that I stop wasting time on this.
Someone is asking, what are the values of X1 and X2?
Okay, I'm gonna go back. Can you say that again?
What are the values of X1 and X2? There was a suggestion that instead of entering the value of the intersect, why don't we just represent it by the cell number 20, cell number B17?
Yeah, it's up to you, but this is just to give you an idea of how it is done. You can decide to choose the cell, to reference the cell. It's just up to you how you want to do. You can reference the cell. This is just to give you an idea of how it is done. You can reference the cell, you can pick the number. It is up to you. But that's just how I put the intersect so that you understand. If you go, let me go to the slide. If you go to the slide.
Mariam, can I interject if it's okay? I just want to introduce two members of our team who have joined the panel to assist you today. So we have Dashan from STEM Hub. So Dashan is going to be helping in the comment section. He's been there since the beginning. And Ibrahim has joined, is also here to help. So if you have any questions, please send it to us in the comment section and we'll be here to help you. We hope everything is going well so far. Thank you, Mariam. You can go on.
So this is the solution that I just showed you, and this is the number. This is the total cost, and this is the number. This is the intercept, and this is the value from the regression analysis, and we multiplied it by 3,000. We multiplied it by this. This is the first unit we want to produce. And this is the second one. And we multiplied it by this and we got this. So I think if the company decides to combine the two, because they have a very strong output for this first one, they can go ahead and combine. But if they want to choose one, they are definitely going to choose the red bike and just keep their resources. So let's go to the third one. Let's go to optimization analysis. So optimization analysis is something very close to regression analysis. It's also used to take decisions for companies. And this is to optimize your process, either to maximize your profit or to minimize your cost. And that's
before we move on, Mariam, can we take a 2 to 3 minutes break? We need help from our participant today. Usually every time when you attend our session, we ask that you help us fill out a survey. Is it okay if I share the survey with the team? Mariam, is that okay?
Oh, yes, fine, fine, fine.
Just give me a second. And today we have a second survey from STEM Hub Foundation. STEM Hub is trying to hit, we're trying to grow our audience and confidence in our brand. And people ask oftentimes who have been beneficiaries of our programs. And we would like you to help us with your testimonials. If during this participation, this has helped you with some clarity, what do you think about STEM Hub Foundation as an organization? Do you think we're doing a great job? Do you think you have had some knowledge to your bank? Do you think you have acquired some good skills out of the different programs we offer? We would like you to help us put this information in a place where we can share it with the public. We're hoping that whatever you share in this second survey, we are going to make available on our website. Please note that we're happy to just maybe put your first name alone or your last name to keep your identity. And the first survey is what I'm putting here. I'm just gonna tag it weekly survey. So I've just loaded up to the comment section, the weekly survey. We would like to hear from you. This is the only way we can make sure we're serving you appropriately. We want to know how this is working out for you. We want to hear about other things. We want to know whether you have affiliation with any of our partners, whether in Nigeria or in Canada. So please help us fill out the survey, the weekly survey for that. For the testimonials that we're trying to gather, I will be, give me a second to post that testimonial link. You may wonder, why do we need a testimonial? As you know, it is as an organization, it is very important for us to be able to partner with other organizations, to also be able to seek for funding from different bigger corporations. In order for us to be able to go out there and seek for funding or ask for partnership, people are looking out to what is our impact? What have we done? If you have been one of the beneficiaries of our different master classes from series 1 till date, we want to know how this has affected you. We want you to help us with your comments, with your testimonials of how you think we're doing as an organization, how we have impacted you, so that we can be able to share this on our website. And when we're trying to partner with people, we can direct them to that place to show that this comes directly from our audience, and this is how you guys are feeling. This is how much impact we have had on your career or on your journey, especially during this COVID-19 when other organizations are completely shut down. Thank you. We will, I just also want to mention that some of you have reached out asking for slides from last week. Some of you have reached out asking us for webinars that we've previously done where Mariam taught us our studio and last week's webinar. We're working on releasing all these videos. We'll make them available on a YouTube channel. And hopefully, if you join us next week, we'll be able to have you visit that channel to be able to watch all the different replays. I want to also let everyone know that next week is going to be really awesome. You've learned data analytics now. So next week, we're moving into artificial intelligence. So next week, we're going to be talking about machine learning. We're bringing Professor Walid. He's going to be leading us on machine learning and computer vision. So if you want to take your data analytics skill to the next level, please come and be a part of this next week. I do not believe that you need to be a computer scientist or to be a coder before you learn data analytics. I also do not believe that you need any of those before you can learn machine learning. I believe that we have assembled the best brains around to come and lead us in this different Industry 4.0 skill sets. We're very excited for who is coming to teach us next week and the topic of interest. I also want to let you know that for the grand finale, you don't want to miss the grand finale of STEM Hub STEM Master Class 2. One of our partner organization called Firmex. Firmex is located in downtown Toronto, is a multi-million-dollar company. Their CEO is going to be talking about how do you scale up a startup. So if you have a startup, you have a small business, you have a consulting company, he's going to come and lead us through what do you do to scale up a startup. So we will make that the grand finale of all our Tech Masterclass 2 series. We're looking forward to that. He's been a supporter of STEM Foundation. They've been donating to us. And during this masterclass, we want to tell you that other things that we don't have on the flyer are going to join this masterclass. Firmex are also sending some of their software developers to lead us into Power BI, into SQL, and they're going to also be leading us in a few other sessions on artificial intelligence. So we're very thankful for the partnership. We're looking forward to these different sessions that are coming up. We hope you are excited as we are, because we're really excited because of the ability to offer all of these very good skills to people for free and help you get to the next level in your career. We're very excited, and thank you again for your participation. I'll hand over back to Mariam. Thank you, Mariam. Mariam, are you there? Thank you. Welcome back.
Sorry, I'm back. So we're going to optimization analysis, and I already talked about, let me share the screen. So I already talked about this, and I wanted to go into the next. Okay, so we're talking about optimization analysis, and I said it is the allocation of limited amount of resources in order to get a maximum output. It's just the same thing as wanting to maximize your profits and, you know, maybe minimize your cost, depending on the kind of resources that you have. And I'm going to show you how this is run. But before you run an optimization analysis, you need three things. You need the objective variable, you need the decision variables, and you need constraint. Your objective variable is the best outcome you want to achieve. Like maybe you want to get your minimum cost, or you want to get your maximum profit. That is the objective variable. That is what you're looking for. And then your decision variable are the factors that will help you to achieve this. You know, like your labor cost, like your marketing cost, like your sales revenue. This is the variable that is dependent on the objective variable. And then the constraint is the limiting factor. What is stopping you from achieving this? So all these are the factors you need to run your optimization analysis, right? So, okay, I just explained this, that the objective function is the equation that is showing the relationship between the objective variable and the decision variable. It could be just like what we did, y equals x1 minus x2. It could be profit equals revenue minus cost. And then the second one is the step to performing your optimization analysis. One, you need to establish your objective variable and your decision variable. And then two, you need to create, this is when you format the Excel sheet that you want to use to run the analysis. You need to format that sheet first before you go to Solver tool. We're going to be using the Solver tool to run this. Remember when we started earlier, we inserted the analysis pack, tool pack, and also the Solver tool. So the Solver tool is what we're going to be using to solve this optimization problem. So the second step is to create the objective function. What is the objective function, which is the equation? And then the third step is to find out what the constraints are. What is limiting you from achieving what you want to achieve? And then this is the example that we have. Example one. A company wants to produce two types of bike, the red bike and the blue bike. If the company sells the red bike, it will make a profit of $20, this one. But if the company sells blue bike, it's going to make a profit of $15. So this is the question. So if this company now sells the two bikes, if they sell all the bikes that they produce, how many red bikes and how many blue bikes are they going to be making, or are they going to be selling to maximize their profit? So that's the question we want to solve right now. So, like I said, the objective, is to find how many red and the blue bike they want to sell to maximize their profit. So the objective variable is going to be to maximize profit right here, which is going to be seen when we are running the optimization model. And the decision variable, they are going to be the number of red bikes to sell or to produce, and the number of blue bikes to sell or to produce. And the objective function is going to be the profit which is the 10, I actually changed the number. So it's going to be $20 of the red bike plus the $15. If you go back to the, yeah, this is the profit, not this. So which is going to be $20 times the red bike plus $15 times the blue bike. This amount here is the profit. If you go back to the previous slide, this is the profit right here. This one and this one. These are the profit. And it's 20, this is 20, and this is 15. Forgive my handwriting. Okay, so to do that, you need to get the data ready. So this is the data we're going to be using to run this. And this is the manufacturing process to make all this bike. And we have the raw material department, the computer fabrication, the plastic, the metal and painting. These are the various departments that the company needs to work in order to make this bike. And this production time is the hours that it takes them to make this bike. So for this raw material, to make one bike, to make one red bike, they're going to spend 1 hour, this department, to make one red bike. And to make one blue bike, they're going to spend 0.9 hours to make that. And the total hour they need is 400 hours. That is their constraint. So for the computer fabrication, the same thing. They're going to spend 0.5 hours to make one bike. And this 3 hours to make one blue bike. And this is their constraint. So all these are the constraint, the availability, the capacity. And these are the number of hours it takes them to make one bike. And this is the profit they will make when they sell this, right? So if it takes the raw material department, So if it takes the raw material department 1 hour to produce one red bike and 0.9 hours to produce one blue bike, and the total hours they have is 400, which is their capacity. This is now the question. How many of these two bikes will they produce in 400 hours? So we're going to solve this now. So if you take them 1 hour, each of these departments, if you take them this number of hours to produce one bike, join together, how many of these will they produce? So we're going to go to the Excel app. I'm going to stop sharing this and go back to Excel. And I'll share this right now. Okay. So I brought that same data into this sheet. We're almost done. So I brought that data back here. So this is the previous data that you were looking at. And in order to run this optimization, we need the solver tool. Like I said, we need the objective variable, which is to the objective, which is to maximize profit. And this is already formatted. If you double click, I'm going to show you how we got this. So to maximize your profit, you need to add the number of red bike that you produce. You multiply it by the profit you're making. If you're making 10 red bikes, you will see this when we run the analysis, because this table is formatted, and I'll show you how this is done. So to produce, to make your profit, you're going to multiply the number of red bike by your profit, the amount you make on each bike, and then you add it to the blue bike. The total number of blue bike you're going to make, you multiply it by the number of blue bikes you're going to be making to know how much money you will get. We don't know this right now because we have not gotten the numbers, and it's only the solver tool that will help us to get this. So we also have the department. This is the number of hours they need. We don't know this now because that's what we want to use the solver tool to get. I also put this so that when we get the data here, we can populate this ourselves and say, okay, if we get all this right, this is going to populate itself, that if they are paying $15 per hour, how much are they going to be paying if they do this? So we could come back to that. So to calculate the number of hours to use, you simply, I already formatted this, so I'm just going to show you how this is done. So you pick the total number of red bikes, you multiply it by the hours, the number of hours it takes raw material department to produce, and then you add it up to the number of blue bike right here. and you multiply it by the number of blue bytes they're going to, the number of hours it takes them to produce one. And then you hit the enter key. And then you do the same thing. So you pull out the equal sign, and then you pick the number of red bytes, and you multiply it by the number of hours it takes to produce one. Then you add it to the blue byte also. You multiply it by the number of hours it takes to produce one byte, and you hit the enter key. You do the same thing for the rest of the department. And then we are just formatting right now. We are on the plastic department, and then you add it to the number of blue bytes to produce, multiplied by the number of hours it takes. You hit the enter key, and then you go to the metal department, equal sign, you pick the number of red bytes, multiply it by the number of hours it takes them to produce one. You add it to the number of blue bytes, and then multiply by the number of hours it takes them to produce one blue byte. You hit the enter key. We do the same thing for the last one. And the number of red bytes multiplied by the number of hours it takes them to produce one, plus number of blue bytes multiplied by the number of hours it takes them to produce one byte. And then you hit the enter key. So right now, we already formatted this. If you don't format this, it's not, I mean, your optimization model is not going to work. You need to format the model, because you're going to use that to run this, this model right now. So to do this, we go back to data. Please let me know if I can take it again or go ahead. Dr. Adi?
There's nothing in the comment section that said we can't.
Okay.
Thank you.
So after formatting the model, once you format, just double click and check that your formula is right. Please always check to be sure that your formula is right. Double click to be sure that your formula is right. So once that's done, you can go ahead and run the model. Go back to data. Click data, go to solver tool. This box is going to pop up. And this is what we're going to use to run the model. So our objective is to maximize profit. And then you click maximize profit. If you want to minimize cost, your objective will be minimize cost. So we are picking to maximize profit. So we click on that, and that's on cell. Let me take this off and show you how that is done again. Come to cell C16. That's where we have our total profit, where our objective function is. And you click on maximize profit. So what are the cells that's going to be changing? The cells that will be changing will be these two cells. We want to know the total red bytes that we want to produce. And you're going to, once you do that, we're going to go to add constraints. We already put our changing cells. So what are the constraints? Remember, our constraint is the available hours that we have. And we want to know the total number of hours, you know, that we are going to be producing. So for the first cell, we are going to pick the total number of hours that we require. It must not be less than or equal to, it must be less than or equal to our total available hours. Whatever we are getting must not be more than our capacity. If not, we cannot do it. Your capacity is what you can do, your budget, available hour, available resources. So our hours required must not be more than our capacity. Of course, if you have any hour that is more than capacity, you cannot do it. So our constraint is going to be the available hours, which is our limiting factor. And then I'm going to click OK because we don't have another constraint again. So I clicked OK, and then we're going to do go to simplest LP because we are doing linear model. So that's why I chose simplest LP for this reason. And once that is done, make sure you click this box and then you click OK. So right now, we have our solution. We have the solution and the solver result says that solution is found. and all constraint and optimality conditions are satisfied. Optimality conditions are satisfied. So I'm going to click OK. Thank you for helping us to solve it. So this is solved. And we can see now that, remember when I think I used this for regression analysis, and red bike seemed to be having the best profit. If you remember the regression analysis that we did, and this is also showing us similar thing. Now the blue bike, you know, we cannot produce anything if we want to maximize our profit. So it's showing us that 0. So it's better for the company to just focus on the red bike in this case, based on the data that we have, and just keep producing the red bike, because the blue bike is not generating anything for them. So we can now see that the number of hours required to produce 400 red bikes is 400 hours, but we have total of 600 hours. So we can decide to increase the number of bikes to produce. I'll come back to that. And then for fabrication, they have 550 hours available, but they can only use 200 hours to produce based on the numbers that we have. So this is the magic. Now, with this, we know that with 400 bytes, if you want to produce 400 bytes, you need this number of hours to produce this. And if you click on the format, there are only 24 hours in a day. So that means to produce this raw material department need 16 hours to produce 400 red bikes. We have seen from the model that we cannot produce blue bike. It's not profitable. I'm taking out the decimals. So the total number of hours that this company needs to produce 400 bikes, I just added it. So it's 1,480. And the total number of days, okay, you might not be able to add this though, but that's fine. So the total number of hours they need is this. So if you want to change it, maybe you're like their consultant, or you're a supply chain person, or you're a salesperson or marketing person, depending on your department. And you say, okay, since we know how much, so if they're going to make 400 red bikes, of course, from this model, they cannot, from their available resources, they cannot produce any blue bike. So this is really out of it. And if they want to add blue bike, let's say they want to add 20, let's say, okay, from what we have, the regression is giving us this. Let's say if you want to produce 50 blue bikes, they put that number. So the parameters change. If you look at the number, it changed. Let me bold in this, because this is what the regression, the optimization gave us. So the numbers change because they increased this number. Now it changed already. I'm going to take this away. Okay, so this is the result that we got. What we were looking is, let me see the question. I'm trying to see the question. So this is how much they can make if they produce 400. So with the capacity they have, they can only produce, okay, that says how many red bikes and blue bikes will they produce to maximize their profit. So to maximize their profit, sorry, I'm just taking it back. Right. So to maximize their profit, they will produce 400 red bikes. So red bike is where the money is. I just added this. So if I just increase the font, and I increase this font too, so the company can now say, okay, this is where we can make our profit. So I added this, that, okay, if we pay $15 per hour, how much are we going to be paying across this to run this promotion? Okay, this is the amount. So the total salary they will be paying people that will be working for them is $22,000. So this model already gave them how much they will be paying. So they already know how many hours they need to work. If we add the number of hours together, we can see they need, days. They need 62 days to do this. If you divide it by months, it's going to be like 2 months and 2 days or thereabout. So it gives them an idea. It gives them an idea of what they want to do, their cost. And then if they now say, okay, we don't want to pay $15 per hour, let's change this. So they decide to change it to $10 per hour. If we don't want to pay too much money, how much are we going to pay? You can see that the amount Okay, okay. Can see that the amount changed because they changed the total money they will be spending changed. So they can use this model to quickly take decision. And if they also say, okay, let's add some more blue bikes to it, and they decide to do 50 blue bikes.
Adeyemi,
yes.
There are a couple of questions in the box. People are asking if you can, we can redo the optimization analysis.
Okay.
Do we formulate the optimization table? How do we do that?
Okay.
Somebody has to start all over again. I don't know what that means, but I think the optimization aside.
Okay, it's okay. I can just take out this numbers. If you take, because what we wanted to find is to solve in the question is how many red bikes and how many blue bikes can we make to maximize our profit. So if you notice, when I took away that number, the old data disappeared. You can see everything disappeared. So I'm going to go back to optimization analysis, and I go to data. And I go to solver. So when you click on solver, this box is going to pop up. The objective is to maximize our profit. So I'm going to click on this tiny box and go to where your objective is. This is the box that we put for the objective. Remember that we already formatted that, this cell here. If you go to the data set that you have, click on that. It's already formatted. And when you click on it, you will see how the format is run. So you click on that, and we are maximizing the profit. So what cell will be changing? Do we want to change? And we already know that the cells that want to change, they are these two. We want to find how many of these two, each of them, we will produce to maximize our profit and not waste our money producing what will not generate money for us. So we clicked on that, and then that's why you see this green line dancing. Then you click add, and then this small box pops up to add our constraints. Our constraint is the limiting factor. Remember, we said that we want to find how many hours we need to produce this by the time we get the number. So the first one, that the number of hours that we need should not be more than the capacity. The capacity is the number of hours that we want to use to produce. That's the available capacity. Whether we like it or not, that's what is available. So that's the limiting factor, not even the money now. The number of hours, if you like, we should have all the money. This is the limited hours that we can use to produce. And we want to find, okay, how many hours do we need to produce this based on the data that we have up here, this data right here. We can't even go beyond this, because for raw material department, they can't do more than 1 hour to produce one bike and 0.9 hours to produce blue bike. So with all this data that we have here, how many hours do we need to produce this number that we don't know yet? So this is going to be our first constraint, and we pick that, highlight it, bring it down, and then pull out this. Remember, this can change. It could be equal to, depending on what you're looking at. It could be equal to your constraint. It could be less than your constraint, and it could be less than or equal to or greater than equal to. But in this case, because we cannot go beyond the capacity, we are saying it should be either less than or it should be equal to the capacity. So we're going to select that, the available hours, which is our capacity, and we select that, and then we click OK. So I don't want this to, I don't know why. Let me delete this. Okay, I deleted one. And let me check the objective. Okay, the objective too is not, okay, so the objective is right now. Let me check this. Please always check your boxes before you click OK. Okay, so this is fine. So the number of constraints that you put will determine, we have just only one constraint. In some cases, people have more than one that they want to solve. So in this case, we have just one. That's why we have one constraint right here. If you want to add additional, just click and go add, click. If you want to change, like just the way I deleted, just click on it. When the blue line is showing, just click delete. And then, okay, so we don't want it to be 0. So, and we don't want it to be negative. So we are using simplest LP because it's linear programming that we are using. So just click on solve, and then it's going to populate. So it gave us the answer, and the solver results now came. It says solver found a solution. All constraints and optimality conditions are satisfied. That means we are good to go. And then if you agree, just click OK. So we have that, and then that's how we got the result. And it's showing that with this data that we have, we cannot produce blue bike. Anyone, if you want to make profits for this business, we cannot. So let me see if I add, okay, so I'll come back to that. So this is the total number of hours that we need if we want to produce 400 bikes to maximize our profit and make as much as $8,000. If you now decide that by force, we know that we cannot make good profits, we cannot maximize our profit if we make zero, if we make any blue buy, but let's see if we can make blue buy and see if we can make money. Okay, so it's added, but some things are to change. The hours change and everything. If you look at the hours change. That means you are paying more money. You understand? You'll be paying more money, and it's the money on top. Look at, we added, let me see if I add only one blue bike. So to produce one blue bike, you are just gonna make just $15 increase. If I take that away, put zero back, and I put 401, let's see how much money we're gonna make. You can see. So if you make one more red bike, you make $20 profit. But if you make this, you're gonna make 15, just as we have here. So it makes some economic sense to make more red bikes. And where this works is the number of hours we need to do this, which is here. We don't know this. So we have available hours for the metal painting, 750 hours, and we're just using 80. So if we add this together now, I hope it's clear now. So the total hours that we need is 1,480, but the available hours is 3,001. So we can actually use the remaining hours to maximize our profit. And this number can keep changing if you increase this to 500. So that's the good thing about the model. Once you run the model, it's just be helping you to increase your numbers. And you can change, you remember I changed this to, I'm going to change this to, let's just say $15 so I can reference that cell. So I just reference the cell and I bring it down. Oh, no, I might have to lock it. Lock the cell. But let me not waste time going into that. That's cell referencing. So, but you get the idea. You can change the number from here and then bring it down. I don't want to go into that right now, because if you don't lock the cell, there's absolute reference, relative reference, and mixed reference. That's another training altogether. I don't want to go there. You can either lock the column or you lock the row, depending on what you want. But this is the idea, and I hope we understand. That's all I have for you today. But you can keep working on it. You can keep changing the numbers. You can, you can add, remove, and then present. Go back to your management that, okay, let's take this up. Let's reduce it. But the idea is that the solver tool has already formatted it, just the way it formatted the regression analysis. Yeah, so basically that is how you just keep changing the numbers and taking your decisions based on that. So thank you. That's all I have for you today.
So much, Mariam. Thank you for sharing your wealth of knowledge with us. Thank you for all that you have been to STEM Hub Foundation. Thank you so much, everyone, for being a part of this. As I have mentioned to you, next week, we will continue on Tech Masterclass series. And next week, we plan to bring to you a session on artificial intelligence, or maybe I should call it machine learning. And we hope that you're following us on our various social media platforms. Please follow us so that you will have access to who is coming, have more information about them ahead of time. If there is anything they need that you have ahead of time, we will have this on the flyer. So please, we want you to make sure you're following us on all our social media platforms. Again, we're so thankful to Mariam for leading us through a 2-week session on very intense data analytics skills. You know, there are some things that I keep wondering. You studied mass communication and you are this number focused. Like, how did you decide to study mass communication if you love numbers this much? We just so much enjoy and appreciate this. And I want to say this to all our participants. Nothing works if you don't practice. You know, everything you have gotten from Mariam, from us, if you don't practice, this is just going to be something you forget 2 to 3 weeks from now. We want to promise you that we will work on putting together all the different recordings on a YouTube channel for you to be able to access from Tech Masterclass 1 up to this point. We hope to make that available to you guys soon. Please stay tuned with us. Again, I just want to thank you, Mariam, for all the things you have done. Please follow TechaVilly on social media. They have wonderful, wonderful initiative currently running in Africa. They're training 1,000 youths on tech skills. So if you have younger ones or you yourself feel like you need more, please register with them on social media. We're very, very thankful. Mariam runs classes on Udemy, and she's a career coach. So if you're thinking, I want to become a business analyst, I think you should follow her on social media and chat her up on what else you need to add to your portfolio to become competitive. Well, we're so thankful again for everyone. My name is Dr. Adiola Olubabuji. You can also follow me on social media because I usually share scholarship information. I help also with dissemination of different ways to make sure that if you're trying to apply for scholarships and study abroad, you are very competitive. Again, thank you for attending this session today. We're very happy that this kind of, it works out. It's short, straight to the point, and there is a lot to catch up on. Please stay tuned so that we will be able to share with you the place to watch or rewatch this if you need it. This is goodbye, everyone, and thank you again. Any last word from Africa Acts team? Is anyone on the call from? Okay, no worries. I think it's a busy weekend for us who live here because this is our Labor Day weekend. We've worked so hard for the entire year. So this is the weekend that people get to celebrate. So it's a little quiet. Thank you all again. This will be the end of our meeting today. We'll see you again, same place, and hopefully exciting topics just like this one for you next week. Thank you. Dr. Abby, you raised your hand. I'm wondering if you, I just allowed you to talk. Dr. Abby, I'm seeing your hand. Is there anything you'd like to share with us? Thank you, Dr. Kalitus. Thank you. All right.